Hi all, welcome to fifth episode of the series Light. In today's topic, we'll be discussing about refractive index. Refractive index shows us how much will the light bend when it goes from one medium to the next medium. Here we consider two different mediums. First medium is here and the second medium is here. Let it be any two different mediums. Now, before saying about refractive index, we have to say about Snell's law. Snell's law states that when a light is coming from one medium to the next medium, then sine of angle of incidence by sine of angle of refraction is always a constant. This constant is called the refractive index, represented by the letter small letter n. Actually, Snell's law gives us the degree of bending of light when the light comes from one medium to the next medium. Here, we need not worry much about sine of angle of incidence or sine of angle of refraction. We have other ways of solving these kinds of questions. We already know that the refraction takes place when the light is coming from one medium to the next medium. It happens because of the difference in the speed of light in two different mediums. So let's imagine the speed of light in this first medium, let it be V1, and the speed of light in the second medium, let it be V2. So we have a shortcut to remember this one. Suppose the refractive index of first medium with respect to second medium, it can be written like V2 by V1. Here, V2 is the speed of light in second medium by V1 is the speed of light in first medium. So, the refractive index of first medium with respect to second medium, that is this medium, we are finding out the refractive index of this medium with respect to this medium can be written like V2 by V1. To remember it easily, just remember, right? If you write here 1, 2, here it should be 2, 1. 2 in numerator and 1 in denominator. Suppose we are finding out the refractive index of second medium with respect to first medium. We can find it out like that also, right? So, suppose if we are finding out the refractive index of this medium with respect to this medium, then it can be written like V1 by V2. Same as I told you just now. So here 2, 1k, we'll write 1 and 2. This is refractive index of second medium with respect to first medium is equal to speed of light in first medium by speed of light in second medium. This n is called refractive index. Here it is refractive index of first medium with respect to second medium, and here it is refractive index of second medium with respect to first medium. Okay, and when 1, 2 comes here, we'll write 2, 1. When 2, 1 comes here, we'll write 1, 2. Then there is one more thing. Suppose if the first medium is air, so this medium is air. We know the speed of light in air, that is usually represented with small letter c. The value of c is 3 into 10 raised to 8 meter per second. This is the value of the speed of light in air. Suppose the first medium is air. Let's use the second equation to write that one. So n to 1 is equal to V1 by V2. Okay. As per this, V1 is same as speed of light here, which is equal to C. So I'll write here C divided by. Now there is no 1 and 2. There is only one medium, whichever medium we are taking here. So the speed of light in that medium can be taken as V. So here there is no use in saying like the refractive index of second medium with respect to first medium, because first medium is already air. So we can simply write it like n is equal to C by V. We write it like this when first medium is air. Okay. In this case, this refractive index is also called absolute refractive index. absolute refractive index. Refractive index. Okay. So we have only seen few things here. First of all, refractive index. Refractive index can be thought of how much the light will bend when it is coming from one medium to the next medium. So we have Snell's law here, which states that ratio of sine of angle of incidence to the ratio of sine of angle of refraction is always a constant. The ratio of sine of angle of incidence to sine of angle of refraction is always a constant. That constant is called n, or refractive index. This refractive index will be a particular value for the object that you're taking, the material that you're taking. The amount of bending of light will be different in water compared to glass, or it will be different compared to air. So, the refractive index of first medium with respect to second medium is equal to V2 by V1. That is, speed of light in second medium by speed of light in first medium. Same way, if you take the opposite, the refractive index of second medium with respect to first medium is equal to speed of light in first medium by speed of light in second medium. Suppose if first medium is air, then refractive index is called absolute refractive index. You can see it here. It's called absolute refractive index. So in that case, the speed of light in first medium becomes c, and in the case of second medium, we need not mention 2 there. It's automatically the speed of light in the medium given. So it will be c by v. So n is equal to c by v. It is called absolute refractive index. Usually we won't say like absolute refractive index. In common, we'll simply say refractive index. So when we say refractive index, what we actually mean is it is the refractive index of the medium when the light is coming from air to that medium. Or actually it is absolute refractive index, which usually we will say like refractive index. Now, here we have a question based on that topic. Let's see how to solve it. So here, the refractive index of medium x with respect to medium y is given as 2 by 3. Let's write that one. As per what we have studied just now, the refractive index of medium x with respect to medium y is given as 2 by 3. Next, so this part is over. Then they have given the refractive index of medium y with respect to medium x z is 4 by 3. So refractive index of medium y with respect to medium z is equal to 4 by 3. Okay. Now find the refractive index of medium z with respect to medium x. So we have to find out the refractive index of medium z with respect to medium x. This is the question. Again, if the speed of light in medium x is 3 into 10 raised to 8, so one more value is given there. Speed of light in medium x is equal to 3 into 10 raised to 8 meter per second. So looking at this value, you understand which medium is it. They have given air as the medium x. Now one more question is there. Calculate the speed of light in medium y. So we have to calculate Vy also. What is Vy? Okay. Now let's analyze the given values. So looking here, first of all, nxy, which means refractive index of medium x with respect to medium y is given as 2 by 3. We know the general equation of the refractive index of medium 1 with respect to medium 2 is written as v2 by v1. Same way here also we'll write the opposite. So here the refractive index of medium x with respect to medium y can be written as Vy by Vx. Okay. Same way here also. Refractive index of medium y with respect to medium z can be written as Vz by Vy. Now the question is to find out the refractive index of medium z with respect to medium x. So what they are actually asking is Vx by Vz. We have to find out this one. Again, we have to find out Vy also. Now, is there any option to make, or is there any option to arrive at Vx by Vz from this one? Vx by Vz. Vx by Vz. Here Vx is in the denominator, Vz is in the numerator. If they were opposite, we could have just multiplied. Okay, then why can't we make it just opposite? Why can't we take the reciprocal of everything? So let's try it like that. Now, V by y Vx is 2 by 3. So here I can write like, therefore, Vx by Vy can be written as 3 by 2. I just took the reciprocal of both the sides. Same way here also, Vy by Vz can be written as 3 by 4. Okay, so I got both these. Now I'll do something. I'll multiply both of these. If this is equation 1 and if this is equation 2, I'll multiply 1 into 2. Then I will get Vx by Vy into Vy by Vz. So Vx, Vy and Vy will get cancelled. I'll just show it here. Vx by Vy into Vy by Vz. So here Vy and Vy got cancelled. So actually what we're getting is Vx by Vz. That is what we have to get here. Vx by Vz. That is same as Nzx. That is same as Nzx, which is refractive index of medium Z with respect to medium X. Okay, now let me write the values of this. That is equal to Vx by Vy. What is the value? Vx by Vy. That is 3 by 2 into, what was V by Y Vz? Vy by Vz was 3 by 4. So now the value that we get is 3 3s are 9 divided by 2 4s are 8. So our first answer is 9 by 8. So Nzx is equal to 9 by 8. We got the answer. First answer is there. Now we'll go for this one, Vy. How to find out Vy? Okay. So now Vy, connecting Vy, let's see whether we have any equation or not. To get Vy, let's see the other given value, that is Vx is given as 3 into 10 raised to 8. So we have to find something connecting Vx, Vy. Here we have it. Take this equation. Vy by Vx is equal to 2 by 3. Let's write that one. Vy by Vx is equal to 2 by 3. Okay, Vy, we don't know what is Vy. I'll write Vy there itself is equal to 2 by 3 into Vx. So, Vy is equal to 2 by 3 into Vx value is already given here, that is 3 into 10 raised to 8. I'll write it there. 3 into 10 raised to 8. See, here 3 and 3 will get cancelled. So the value of Vy will be 2 into 10 raised to 8 meter per second. That's it. So we got both the answers. So the value of Vy is 2 into 10 raised to 8 meter per second. That's it. So if you get questions like this, try to solve it like this. Thank you.